Every AI assistant has a dirty secret. It forgets. Not slowly, like a person losing their keys. Completely. Every conversation starts from scratch. And even within a single conversation, there's a hard wall, the context window. Think of it as a desk. A small desk. Every piece of information you share takes up space. Your project files, your preferences, your past decisions, they all pile up. And when the desk is full, things start falling off the edge. This is context entropy. The gradual decay of useful information as your workspace fills with noise. So how do you solve this? How do you give an AI agent a working memory that stays sharp and never overflows? Imagine a 5-star hotel. Hundreds of guests, each with unique preferences, histories, and requests. The concierge manages all of them. But here's the thing, a great concierge doesn't memorize every guest's life story. That would be impossible. Instead, they use a system. In their breast pocket, a small notebook. Names, room numbers, key facts. Fit on a single page. Behind the desk, a filing cabinet. Full guest profiles. Pulled out only when that specific guest approaches. And in the back room, security camera footage. Vast. Archival. Only checked when someone needs to verify a specific moment in time. 3 layers. Pocket notebook. Filing cabinet. Security footage. Each serves a different purpose, at a different speed, with a different level of detail. This is exactly the architecture we need for AI agent memory. The Pocket Notebook is MEMORY.md. It's a single file, always loaded into the context window. Always available at a glance. Each line is compact, about 150 characters. Just enough to store a pointer. Authentication system, see authsystem.md. User prefers dark mode. Last deployment, March 15th. Think of each line as a room number, not a biography. The concierge doesn't need to know Mr. Smith's entire travel history to greet him by name and remember his shellfish allergy. This file is special because the agent can write to it. When something important happens, a new decision, a new file created, a key preference learned, the agent updates the notebook. But the notebook has a strict rule: keep it slim. If the pocket notebook becomes a briefcase, you've defeated the purpose. Every entry must earn its place. When a guest approaches the desk with a specific question, the concierge doesn't guess. They turn around, open the filing cabinet, and pull out that guest's complete profile. In our system, these are topic files. Standalone markdown documents, each covering one domain: the authentication system, the API design, the user research findings. The keyword is on demand. These files are not loaded by default. They sit quietly in the filing cabinet until the agent recognizes it needs one. This is lazy loading applied to knowledge. Most conversations only need 1 or 2 topic files. Loading all of them would be like the concierge carrying every guest's folder in their arms at all times, exhausting and unnecessary. When the topic file arrives in context, the agent has deep, detailed knowledge about that specific domain. When the conversation moves on, the file can be released, freeing up space for the next topic. Now imagine a guest says, 3 weeks ago, I spoke with your night manager about a noise complaint. What happened? The concierge can't answer from the notebook. The filing cabinet doesn't cover individual incidents. For this, they need the security footage. Raw transcripts are the archive, every conversation, every exchange, stored in full. It's massive. Unstructured. You would never watch all of it. You would never load it into the context window. Instead, you search it. grep. A targeted query that dives into the archive and surfaces exactly the passage you need. This is the deepest layer. Highest volume, lowest accessibility. It exists not to be browsed, but to be queried with precision. Let's watch the system in action. A guest arrives. They want to continue working on the authentication module. Step 1. The concierge checks the pocket notebook. There it is, auth system, see authsystem.md, last updated April 3rd, instant recognition. Step 2. The agent fetches authsystem.md into the context window. Now it has the full picture, the architecture decisions, the token format, the edge cases documented last week. Step 3. The guest mentions a conversation from 2 weeks ago about a specific bug. The agent greps the raw transcripts. Finds the exact exchange. Pulls the relevant snippet into context. At no point did the agent load everything. The context window held only what was needed, when it was needed. This is the cascade. Notebook points to files. Files point to transcripts. Each layer filters and focuses, so the context window always contains signal, never noise. This architecture rests on 3 principles. Let's examine each one. Principle 1. Store pointers, not data. The notebook holds room numbers, not biographies. MEMORY.md holds file references, not file contents. This keeps the always loaded layer impossibly lean. Principle 2. Fetch on demand. The concierge doesn't carry every folder. The agent doesn't load every topic file. Information arrives exactly when needed and leaves when the conversation moves on. This turns a fixed-size context window into a rotating spotlight, small beam, but it can illuminate anything. Principle 3. Update the index only after success. The concierge writes in the notebook only after confirmed check-in, never before. The agent updates MEMORY.md only after a file is successfully created or a decision is confirmed. This prevents phantom references and the worst kind of corruption, an index that points to something that doesn't exist. Context entropy is the silent killer of AI agent performance. As projects grow, as conversations multiply, the context window fills with noise. The 3-layer memory architecture, inspired by how the best hotel concierges work, solves this by separating what must be remembered, what can be retrieved, and what should only be searched. The pocket notebook stays slim. The filing cabinet stays organized. The archive stays searchable. And the guest? The guest always feels remembered. Store pointers, not data. Fetch on demand. Update index only after success.